So the digestive system. When we think about the role of the digestive system in homeostasis, its job is to begin metabolism by providing those nutrients for us to break down and turn into ATP, right? So we have to bring in food into the digestive tract. We have to break it up. It comes in, potentially, if you're eating pizza or a sandwich or chips, we have to break it into a liquid. That's the job of the stomach. And then we send it to the small intestine where enzymes are added with the help of the pancreas and bile from the liver and gallbladder. That breaks it down into small little bits that can be absorbed through those columnar cells of the small intestine. So by the time it reaches the end of the small intestine, which is called what? What is that last part of the small intestine called? That's the beginning is the duodenum, the middle is the jejunum, and the end is the ileum. Yeah, so by the time it reaches the ileum, that food is liquefied, bacterial count is increasing, the good bacteria of our gut that helps with digestion, and then it moves to the large intestine. And the job of the large intestine is to take that liquid stuff, waste product, and some extra ions that are important, like bicarbonate ion, needs to be absorbed back to the blood with the help of the large intestine. So water is also absorbed from the large intestine. So if there's enough time in the large intestine, in a healthy gut, we should not see watery, loose stools, right? We should see solid, soft stools. If it spends too much time in the large intestine because of constipation, we see hard stools. And because of the smooth muscle contraction in the large intestine, the stool gets tossed around in there in the end of the large intestine. And what does it look like when it comes out in a person that's really constipated? Little balls, right? Little rabbit pellets, is the shape of it, because it's been tossed around too long in that large intestine. So we're going to talk about each part of the digestive tract and the accessory organs in their role of digesting and absorbing nutrients. That's the key. We got to get those nutrients to cells so they can build their products, whether it's building a protein, a lipid, we need to, or other types of carbohydrates. We need to bring those building blocks in. But the building blocks are not ready to go, right? We got to digest them down into the building blocks. So looking at basic parts of the digestive tract, then it starts with the mouth. Digestion begins in the mouth because we have saliva that has the enzyme amylase that breaks some of those starches down, turning it into a liquid. Then it passes to the esophagus, then to the stomach, to the duodenum, which is that first part of the small intestine. I'm going to make this a little bigger here. So the duodenum is this first part of the small intestine coming from the stomach. So most digestion occurs here. So this is where all the nutrients that need to be broken down into their building blocks. So proteins need to be broken down into what? What's the building block of proteins? Amino acids, yeah. And building blocks of sugars like starches, polysaccharides, and sucrose disaccharides, glucose and fructose, right? Those are the smallest building blocks that we can absorb. And then we look at DNA, that's broken down into its nucleotides. Fats are broken down into fatty acid and glycerol. Those are all tiny things that can be absorbed into columnar cells. If we can't digest them down, if the enzymes are not there to digest those things into those building blocks, they stay in the small intestine and they get into the large intestine, and the large intestine says, what the heck is this big stuff? We can't handle this. So then the large intestine gets inflamed and angry, and people have diarrhea, constipation, gas, bloating. They're miserable. What are examples of that? Celiac disease is one. They can't break down and respond to gluten. It causes an allergic reaction. And another one is lactose intolerance. If people bring in lactose and it's not digested in that small intestine, it gets into the large intestine, and the large intestine can't deal with that sugar, and then it causes lots of pain and cramping and diarrhea or constipation and gas. So makes people pretty miserable. So they can take an enzyme. So they can take the enzyme lactase, right? It's a little pill people can buy, and then they can eat dairy products. Some people can. Some people can't do it at all. If a person has cystic fibrosis and their pancreas is clogged with mucus, the pancreatic duct, those nice pancreatic digestive enzymes that go to the duodenum from the pancreatic duct, those don't make it there, And those people have fatty, how do you describe it? Just fatty, kind of smelly stool, because it's not, those things are not digested in the duodenum because there's so much mucus from the symptoms of cystic fibrosis. So then it gets down, like I said, into the jejunum, which is a majority of the small intestine. We see here in the middle, and then at the end is the ileum. Then it reaches the large intestine. So the accessory organs are the liver, the pancreas, and the gallbladder. And the reason why we say accessory is that food does not pass through these organs. All they do is have ducts that lead to the duodenum to help digestion occur. So they're accessory. But what food actually passes through is this piping network. So we don't need to bring in anything sterile, because this digestive tract from mouth to anus, this whole list of structures, is set up to prevent infection. But what happens if the wall of this piping network breaks? Like you have a perforated colon from a gunshot wound, or an injury in a car accident, or an ulcer that goes untreated and eventually burns a hole in the stomach or the small intestine. Now you have a leak, or a burst appendix. Now you have a leak in this digestive tract, and that's going to cause major infection, which we call peritonitis. So we don't want to break in this network. So we're kind of like a donut. If you can simplify the human body down to a donut, the cake of the donut is the sterile part, and the hole in the middle is the mouth to the anus, if you think about it that way. So if there's any break in that, into that sterile cake, there's infection and problems. Okay, so know the order as it passes through. Remember that pharynx is the throat, and then it passes to the esophagus. So the job of the upper digestive tract is when we get food down into the mouth, down the esophagus, into the stomach, we have to first, to get it ready to go to the stomach, we have to chew it. And the process of chewing is called mastication. To masticate is to chew. Remember the masseter muscle that is in the, right in front of the ear? And if you clench your jaws, you can feel it kind of bulge out. That is what helps us chew. So mastication is a process of chewing. So as long as we can chew well, we can roll it around with our tongue and get it nice and mushy to be swallowed. And we call that mushy ball of food that we've chewed a bolus. So once we get that food from a bunch of taco chips with some cheese on it into a soft bolus, we can swallow it down, or a sandwich, or a piece of pizza. And then it moves down the esophagus by a process called peristalsis. Peristalsis are waves of smooth muscle contraction that move things forward through the tract. So it's like a rolling contraction of that muscularis layer, moving the food downward or along to the next organ. So if I'm hanging upside down and I take a bite of a peanut butter sandwich, will that food go from my esophagus to my stomach after I swallow it? Yes. So I can hang upside down, and that'll still happen because of that peristalsis. The bad part about that is once it's down the hatch, you can't get it back, right? And when I was a new nurse in clinical, that was my biggest fear, is when I'm going through these medicines and I hand that cup over to the patient and they just go, you know, they just trust you that you figured it all out and you're giving them the right dose and the right pills. And I'm like, you know, I just hope I did this right, but you know, at home we take Tylenol or give Tylenol to our kids or our friends, no problem, right? But when you're responsible as a nurse, it's very intimidating in those first months in nursing school, or at least it should be, because it's serious stuff that you're doing. If you make a mistake, you know, once it's down the hatch, you're in trouble. So peristalsis is that smooth, kind of one-directional squeeze. And then if we look at segmentation, segmentation is little bits that squeeze in one section, so little segments of the wall are contracting. And we see that primarily in the small intestine. So that kind of helps the food move back and forth and liquefy it some more and give it exposure to those columnar cells for further digestion and absorption. Because what do these cells have? Do you remember what small intestinal cells have that helps increase the surface area for absorption? Not cilia, but if we take that plasma membrane and extend it into little finger-like extensions, do you remember what we call those little finger-like extensions of the plasma membrane? Microvilli, very good. Microvilli is what helps increase surface area, and that's what we see on these columnar cells, to increase, you know, the surface area. So this kind of just mixes the food back and forth. So when you look at, again, the small intestine, the lower GI, we see this, kind of squeezing on either side of that food, turning it into a liquid till it's kind of spread throughout that piece and can move along. So mixing, secretion, digestion, absorption, these are all jobs of the small intestine. And then elimination is the job of the large intestine. Whatever's left over that we don't need, what hasn't been absorbed, leaves the body through the anal opening. So when you look at secretions that are added to kind of help this whole process as before it gets to the large intestine, we have mucus secretion, hydrochloric acid in the stomach, and different digestive hormones that are released by the stomach and small intestine, as well as enzymes, again, some of which are released by the microvilli. There's enzymes that are released. Those columnar cells differ a little bit in their function. We'll talk more about that in advanced A&P, but some of them secrete specific hormones, and like I said, enzymes from the pancreas as well as the small intestine help with that. So once we absorb through the walls of those columnar cells, through that mucosa, there's capillaries outside of that that pick up those absorbed nutrients and then take them to the rest of the body. Just like we saw in the alveoli, right? The alveoli bring in the oxygen. There's pulmonary capillaries wrapped around those alveoli that pick up that oxygen and then deliver it to the body. So the same thing happens in the digestive tract. These columnar cells of the different digestive organs, particularly the duodenum, jejunum, ileum, more duodenum and jejunum, have capillaries wrapped around them that pick up those absorbed nutrients and take it to the rest of the body. But it has to pass through the liver first. That's one unique thing that we see in the digestive tract, is it doesn't go everywhere. It doesn't go directly to the inferior vena cava. These absorbed nutrients have to go to the liver first. So what does that mean if I'm drinking a lot of alcohol? The absorbed alcohol goes to the liver first, right? And that's why we see liver damage in people that are big drinkers, because that's where it passes first before it goes to the inferior vena cava and to the brain to get the effects. So people are drinking to get those effects, but it has to get to the liver first from the stomach and small intestine. Okay, so starting off then with this tract, it starts in the mouth. Digestion starts in the mouth with the saliva, because the saliva contains an enzyme called amylase. Make sure you know the function of amylase. It helps break down starches. So I can give a baby with no teeth, I can give them a saltine cracker, and that'll turn into a liquid as they kind of just gum that cracker, and then down it goes. And there's also a little thing, it's a little kind of an oblong, it's about maybe 4 inches long, it's called Zwieback Toast. And my kids love that, and they would suck on it and hold it and get it all soft and get it down. But then what happens when that little Zwieback Toast is about 2 inches long, an inch wide, and all soggy on the outside? You think that's a choking risk? Because if they shove that whole piece in and it slips down their throat and they can't swallow it, definitely a choking risk. So those soft foods that are bigger but hard in the center, you got to really be careful with, because kids can choke on that. Little bits of cracker are great. And I was at a family gathering one time, and my little 1-year-old was toddling around. It was Allison, actually. And she was eating crackers, and I was giving her crackers. There were Ritz crackers out with some cheese. I wasn't giving her the cheese, but I was giving her Ritz crackers, little bits of cheese, but the Ritz crackers, and she was eating those. Well, then my dad gave her some taco chips, some tortilla chips. Are those pure starch, or is there a lot of ground up corn in there that's not going to break down? So all of a sudden I look, and she's choking, and I reach down her throat and pull a big taco chip out, and I'm like, where did she get the taco chip? And my dad said, well, I gave it to her. I saw you giving her the crackers. Well, that's, different, because there is not an enzyme to break down that cell wall of those pieces of corn in taco chips. Oh, right, yeah, exactly. Nothing in the digestive tract, yeah. So amylase is for starchy things. Okay, looking at the next part then, so once it passes from the mouth, it enters into the esophagus, and there's a number of different mechanisms for swallowing. There's the voluntary phase that is controlled by the brain, called the cephalic phase. It enters in, and we voluntarily push it to the back of the throat, and we're ready to swallow it. If it enters the back of the throat before we voluntarily are aware of it, what happens? The gag reflex kicks in. The gag reflex kicks in. And that's good. That forces it forward, right? So that's good. But as long as we voluntarily push it back, we're okay. And that reflex in people as they age diminishes. And the elderly are much more at risk for choking. So we really got to be careful with the elderly and make sure they're sitting upright in bed. Because I can't tell you how many times I've had a patient that's almost flat with their chin against their chest and they're reaching like this for me to give them their medicines. And I'm like, no, we got to sit you up and, you know, oh, that's good enough. That's good enough. No, it's not. We got to keep getting you upward because we don't want you to choke. And then if someone has a swallowing problem, should they tilt their head back when they're drinking? No. The suggestion is actually to lower the chin while they're drinking so they can consciously control the swallows that go to the back of the throat. So really, really important. So the oropharynx is what transmits food, right? The nasopharynx is for smelling and mucus production and, you know, lubrication, but it's definitely not for food. If you've ever vomited, heaven forbid, and the forceful upward propulsion sometimes causes vomit to enter the nasopharynx, and it's very painful, right? That acidic contents in the back of the nose, pretty miserable. Then you blow your nose and there's lots of good stuff in there. Yuck. Laryngopharynx transmits food, and that's just before we get to the, you know, just behind the larynx, and then it goes down to the esophagus. Esophagus takes it to the stomach, and there's different sphincters. There's an upper esophageal sphincter and a lower esophageal sphincter. So the lower one is the one that causes problems, and that's this one here. The lower esophageal sphincter can sometimes spasm if people drink or eat acidic foods. Coffee and alcohol are all things that cause spasms of the lower esophageal sphincter. And it's also called the cardiac sphincter. We learned that in lab, right? And that's what causes reflux, acid reflux problems. So people with acid reflux, symptoms of that is when they eat something like a big meal, and then maybe a half an hour after that big meal, they have a cough. Not a bad cough, just like mucus is kind of building up in the airways, and they kind of go, If that happens to you or someone you know after eating big meals, that's a sign of acid reflux, because what's happening is some of that acid from your meal you just ate and the large meal is causing that lower esophageal sphincter to open up, and some acid is backing up into your esophagus. And as acid builds up into the esophagus, it stimulates mucus production throughout the tract, and you have mucus production happening in the laryngopharynx, and then you feel that urge to cough. So that's not a good sign. And there's a lot of really good acid reducers out there. There's Zantac, Prilosec. Have you heard of omeprazole and ranitidine? Those are really good antacids for long term, especially tomorrow is Thanksgiving, right? So some people might consider taking an antacid in the morning so you can handle, you know, the large, I mean, is that a great idea to have large amounts of food? Is it a reality? Yes, right? So, you know, sometimes an antacid for people that are at risk, taking one of those long actings in the morning can help you tolerate that a little better. Yes?
Does it affect everything gets up into the nasopharynx? Does it feels like acid up there?
Yes. Yes, definitely. It can cause a burning sensation in the back of the nasopharynx and mucus production. Yeah. Does he take a long-acting antacid? He should. Yeah, those are fighting the fire. That's like throwing water on the fire, where if you soak the wood with water ahead of time, the fire wouldn't start, right? So that's what taking those long-acting before you eat is the best preventative, like a couple hours before. So they say a half an hour before you eat, but I have had issues, so I take one in the morning and then I take one maybe an hour before. This depends on the medicine. Not really. Omeprazole, yeah. I've had pretty good luck with that medicine, but long term, omeprazole is not really good for you. No, but there's other issues. I don't want to spend a lot of time on medicine stuff, but they recommend if you can be benefited by Zantac, that one has less long-term side effects than omeprazole does, so they recommend people do that. And they prevent acid secretion. So that's the good thing about that. What Tums does, it just lowers the acidity in the stomach. It's a base, basically, that you're taking. Baking soda is a really good base that people can take, and if you don't have any Tums around, it tastes terrible. Take a teaspoon of baking soda and about 2 ounces of water, maybe half a teaspoon even. Stir it around, knock it back fast, and it's a great, what? Yeah, yeah. And it'll drop that pH, or raise the pH and make you feel better. Because sometimes when we eat a lot of food, our stomach just, did you ever have it when you eat a lot of junky food, or maybe you're kind of stressed and you eat a meal and it feels like it's just sitting there and it's not digesting? Or maybe if you've ever had the stomach flu, you eat a meal and it's like, I still feel like my stomach is full and it kind of feels liquidy, right? Like it's just not moving. Sometimes if it's related to just not eating well and a lot of junk, or maybe mixing alcohol or soda with a lot of rich foods, those digestive enzymes stop and the acidity is dropping as more and more hydrochloric acid is being produced by the stomach. Acidity is dropping and digestion is kind of impaired. So you throw a Tums in there and you raise that pH, then all of a sudden the enzymes are activated and then digestion can occur. And people really feel a lot better after they've eaten too much, throwing some Tums down there to raise that pH and get those enzymes working. And then all of a sudden the bloating sensation is gone. And bloating, when I say bloating, I'm talking about upper GI bloating, so just below the ribs to the left is where your stomach is. If you have bloating around the belly button and below, that's large intestine, small intestine problems. And that's, you can't affect that by taking an antacid because it's out of the stomach by that point. So the laryngopharynx extends from the glottis to the epiglottis to the larynx. We've already talked about that with the respiratory system. But when we swallow, that breathing stops, right? Because the esophagus opens up, epiglottis is covering the larynx, and food is directed to the stomach. We talked about the importance of the rugae in the stomach wall, and that those cause an infinite ability for the stomach to stretch. Not infinite, but pretty large. That stomach can stretch up to 2 gallons of food. And then it develops a new resting length. And that can be bad for us, right? Because if we keep stretching with too much food, like people with binge eating disorder, they eat large volumes of food at one time, they have a large resting volume of their stomach, which means they feel the sensations of hunger earlier. So small amounts of food throughout the day is the best way to keep your weight under control and have a healthy digestive tract. So if we look at a typical stomach wall, we see these little holes, little indentations of the stomach wall, and there's these deep pits that are lined with columnar cells. So each of these pits are different columnar cells with different jobs. And when we get to advanced A&P, we'll talk about the functions of those different columnar cells. Like the ones near the top are mostly mucus. And this is a test question. What is the benefit of mucus lining that stomach wall? What does the stomach produce, did we say? What type of acid? Hydrochloric acid. It's one of the strongest acids out there. So if it secreted hydrochloric acid and had no mucus lining, coating, what would happen to the walls of the stomach? It would be destroyed by that acid. So the fact that there's a nice mucus coating that protects the stomach from that hydrochloric acid and causing an ulcer like we see here. This is a nasty little ulcer. That's actually perforating the stomach wall, and that could lead to, penetration and peritonitis, right? Because that's not sterile stuff. So there's all different types of cells. You don't have to know the name and the function of these cells. Just know that the stomach releases hydrochloric acid, intrinsic factor, which helps us absorb vitamin B12 to make red blood cells. Pepsinogen is to break down proteins. And then there's different hormones, like gastrin, that the stomach secretes. But you don't have to know that for general A&P. But you do have to know hydrochloric acid, intrinsic factor, and pepsinogen. Those are the major secretions of the stomach. And again, the functions, hydrochloric acid, that helps us digest foods into smaller bits and pieces. It's a little fancier than that, but we'll get into that in advanced A&P. And then intrinsic factor helps us absorb what vitamin? B12. And why do we need B12? Red blood cells. So just think, if you don't have enough intrinsic factor, you don't have enough vitamin B12 entering your blood, you're not going to have enough red blood cells, and the symptom of that is anemia. Pernicious anemia is called, pernicious anemia. But again, you don't have to know that term. Just know intrinsic factor secreted by the stomach to absorb vitamin B12 to help us make more red blood cells. And pepsinogen is for protein, breaking down protein into amino acids. So peristalsis in the stomach, it's a back and forth, turning that bolus into a liquid called chyme. Make sure you highlight and underline this term. It's called chyme, not chime. That's what the bells do in the church bell or whatever, bell, what's it called, the belfry? Yeah. That's a C-H-I-M-E. This is called chyme, hard C. Like choir, right, is a hard C, but it's C-H. So chyme. So it enters, so once this is all liquid, and you can tell, like when your dog throws up on the kitchen floor and it's a pile of soft dog food, you know that digestion didn't even start yet. That food entered and right back out again. But when your dog or cat throws up a nice yellow, nasty, that's an empty stomach, right? Or if it's just a stinky, multicolored thing, then you know that's chyme. That was digested for the most part, but not all of it made it into the small intestine, because we only put food in the small intestine 3 mils at a time. That's less than a teaspoon is entering that small intestine with each little contraction and opening of that valve, that pyloric sphincter, right? And the problem with that is, so if you have a belly full of alcohol and you think you're good to get in the car and drive home, well, is all that alcohol absorbed if it's 3 mils at a time? No way. But how can we speed things going from the stomach to the small intestine? Anytime we have fatty foods in the small intestine that help speed things through the tract. People have noticed, like runners will say, I got to get my bowels emptied, I'm going to do the McDonald's cleanse. They know if they go have a big fatty McDonald's lunch with a quarter pounder with cheese and fries, that fatty lunch is going to stimulate a bowel movement within about an hour. Where people have like a salad and just carbs, that doesn't stimulate bowel movements as much. Or if you're going to go out with a night of drinking for friends, let's say you have to go to a bachelorette party and it starts early and you're going to be drinking all night and you want to be responsible, right? Be sociable but responsible. Never go on an empty stomach. Never say, I'm just going to eat a salad before I go out. I'm just going to have a little bowl of pasta or a peanut butter or a jelly sandwich. Bad choice. Something with a little bit of fat and protein in it is going to slow the absorption, because it takes more time in the small intestine or in the stomach to move that into the small intestine, and that's going to keep that alcohol in there a little faster or a little longer. So it's slowing the movement into the small intestine. So when we eat really carb-laden foods, those leave the stomach faster and make you hungrier quicker. Would you not agree? When I have cereal, toast, bagel, pancakes for breakfast, I'm starving in about an hour and a half. My stomach is growling and saying, give me more food. But when I have eggs for breakfast, that sticks with me for probably 3-4 hours. Try it as an experiment sometime. If you find that your blood sugar drops after you eat breakfast, you get kind of shaky, sweaty, and like, oh my gosh, I'm starving, I have to eat. Women commonly have hypoglycemia, where they don't secrete a lot of glucagon to keep blood sugar levels up between meals. High sugar meals, high carb meals, even if it's healthy carbs like whole wheat toast or pasta, whole wheat pasta, still that burns through the tract really fast, goes through the digestive tract really fast, spikes blood sugars, and then causes insulin surges and blood sugar crashes. So throw some protein in with your breakfast if you want to not be hungry so quickly and be looking for more food. That's why we tell our diabetics, if they're going to have a snack, going to make a sandwich, put some peanut butter on that sandwich. Good source of protein that'll keep your blood sugar stable, rather than just eating, carbs. Like French fries, very bad. All carbs, right? They're going to make you hungry. All right, small intestine. It's bolded and underlined. So that probably indicates very important concept. The small intestine's job is to digest and then absorb those nutrients. There's microvilli on these cells again. And there's a little green structure that absorbs fat. It's called a lacteal. And there's the capillaries to send it to the blood, pass through the liver, and then go to the rest of the body. So we'll pick up next time talking more about the role of the small intestine.